In this video, I'll introduce the notion of a symmetric relation. Suppose we have a set, let's call it A, and then using this set we can define a relation on the set A. So we can define a relation R, which is just a subset of the Cartesian product of A with itself. And we say that the relation R is symmetric if we know that for all elements of A, so for all elements xy of A, if we know that if the ordered pair xy is an element of R, then this immediately implies that the ordered pair yx is also an element of R. So if we know that this statement is true, then we can say our relation R is symmetric. And another way to write this is to say for all elements xy, if x is related to y, then this immediately implies that y is related to x. So if this statement is true, then this statement must be true, and if this condition is satisfied, then we can say the relation R is symmetric. Now let's take a look at an example. Suppose A is the set consisting of the numbers 1, 2, and 3. Now let's define our relation R to be the set consisting of the ordered pairs 1, 2, 2, 1, and 1, 3. Now this relation R is not symmetric. So this is not symmetric, because you can see that although 1 is related to 3, you can see that 3 is actually not related to 1, because the ordered pair 3, 1 is not an element of the set R. And you can see that this clearly violates this statement over here. So if you want your relation to be symmetric, if x is related to y, in our case is if 1 is related to 3, then it also must be true that y must also be related to x. So we have to, if R is symmetric, then 3 must also be related to 1. But you can see that in our case, 3 is actually not related to 1. So this violates this statement over here. So it does not satisfy the condition for the relation to be symmetric, and so that is why this relation R is not symmetric. Now let's take a look at another example. Suppose this time A is still the set consisting of the numbers 1, 2, and 3. And let's say this time R is the set consisting of the ordered pairs 1, 1, 2, 3, and 3, 2. Now for this relation, this is definitely symmetric. So this is symmetric. And this is symmetric because we can check that for every single pair in R, its inverse is also in R as well. So you can see that 2 is related to 3, and also 3 is related to 2. And also for the ordered pair 1, 1, this is kind of trivial. You can see that this automatically satisfies this statement, because if 1 is related to 1, then of course if you flip it, you still get 1 is related to 1. So automatically this statement is true. So you can see that for this relation, it is symmetric because it satisfies this statement over here.